Hi everyone, welcome back to Art of the Part. In this video, we're going to continue on with the ye olde pop topper case study. In the last video, we talked about processing a DXF in such a way that it was separate from the 3D parametric model that we ended up tracing from it. So if I actually click on the reference sketch, that was the imported DXF that I had. If I click on it and delete it, none of the other geometry is going to be negatively effective because I didn't link it that way. We toggled back and forth by turning the sketch on and turning it off and referencing it only to take measurements. We weren't actually creating geometry from the sketch that we imported. So it's fully editable now. I can go into the sketch and I can change the values as I need. So I'm actually just going to turn off my reference sketch. I don't need to delete it. I do want to keep it there just because it's good practice to have it in the background. So I'm just going to hide it. And what I'm going to do now is I'm going to create or set up a handful of different configurations to apply material to so I can import that into a finite element analysis or a simulation study. So what I'll do here is in the left-hand side of the SolidWorks screen, we have our feature tree. This is where all of our features, our sketches are chronologically logged, but then we also have a configuration manager, which is going to be 2 tabs over from the feature tree itself. So we see that we have the yellow Tetris piece. That's where all of our information of the geometry is stored. But if we go over here to the stem with the 2 boxes to the right of it, we have the configuration manager. So if I click on the configuration manager, which is right here, I have the option to start creating or deleting or changing different configurations. So I have a default that is always standard whenever we start a new part. We're always going to see a default there. But what we're going to do is we're going to create a configuration for 6061. We're going to create a configuration for 356. And then we're going to create a configuration for the prototype plastic that we're going to 3D print. So what we'll do is we'll right-click over here in the free space of the configuration manager, and we're going to select Add Configuration. So we'll add a configuration name for 6061, and if you want to be more specific, you can type 6061 T6 aluminum. We can also go to Add Configuration. We can go with 356, and we can name that cast aluminum if we want. And we'll repeat the step one more time by right-clicking, Add Configuration, and we'll just title this one Plastic. And if I ever wanted to change or delete one of the configurations, I could always just right-click on one of them and either choose Delete, or in this instance, I have a default one that I want to change or convert into a machine configuration, which will be helpful for when we start importing it into Mastercam. For example, Mastercam is a little bit easier to program to when we have sharp edges for chamfers and edge breaks. So I'm actually going to suppress the chamfers in this machine configuration, but I'm going to leave them on for all the other configurations so that they're present for the FEA studies. So what I'm going to do is I'm going to right-click on Default, I'm going to go to Properties, and I'm going to change Default to Machine. And I'll change the description of it to Machine as well. And then I'll hit the green check mark. So now I can toggle between these different configurations, and I can apply or suppress different materials or features. So I'm just going to double click and I'm going to toggle through these. And first and foremost, I'm going to go to 6061. And when I click on the 6061, I want you to get in the habit of, and whenever you're clicking on these configurations, I want you to get in the habit of going from the configuration manager to the feature tree. So we're going to hop back over here into the feature tree after we've selected 6061. We're going to go and find material. You have it, an option that says not specified or a description that says not specified. And we're going to right click on it and we're going to choose edit material. We also have a handful of favorite materials that are set up or preset. Mine, I already have 6061, but I want to show you how to actually locate it or any other material. So we're going to click on Edit Material. And we're going to be prompted with this material window. We're going to collapse steel, and we're going to see a handful of different material families. So I have steel, iron, aluminum, copper, titanium, zinc, other plastic, so on and so forth. So I can go down here to, say, aluminum. I can click on aluminum. I can hit the arrow to the left of aluminum to open up all these different aluminum types. And I'm going to scroll down until I find 6061 T6SS. I want to find T6 because that's the specific material that we are using in this class. So I'm going to click on T6, and I want to get in a good habit of changing it from, if it's defaulting to SI or English, I want to be in megapascals, which is newtons per millimeter squared. So I'm going to select megapascals. And you'll see that I can identify the tensile strength, which is the ultimate breaking point, or I can choose the yield strength, or see the yield strength, which is the point where it passes from elastic deformation to plastic deformation. So I'm going to go ahead and click Apply. And I want you to keep these values in mind, especially when we're going from like a forged aluminum, which is 6061, to say a cast aluminum with this 356. So keep in mind tensile strength of 310, yield strength of 275. All this is saying is the appearance is going to change for this configuration. Do you approve that? You're going to hit yes. And then you're going to hit close. So then you're going to notice that the material may have changed color slightly. And then we're going to hop back over here to the configuration manager. Then we're going to choose the 356. And it's going to default back to its original color. We're going to go back to the feature tree, and we're going to do the same thing. We're going to right-click on the material. Again, its description is not specified. Click on Edit Material. We're going to collapse steel. We're going to go to aluminum, scroll down until we find 356, which is a permanent mold cast. Click on that. Again, get in the good habit of changing the units to newtons per millimeter squared, which is megapascals. And then again, I told you to kind of keep in mind the tensile strength of a forged metal versus a cast metal, because the tensile strength was 310. And I think what's pretty impressive from a forged to a cast is that the yield strength is almost like half. It's just a little bit above. So we see that the yield strength is actually 152 versus 275. So in our minds, we have to start imagining that the cast aluminum in this application is about half as strong as the forged aluminum. So when we're applying the forces, we might actually have to apply a thicker cross section to get the same performance. So what we'll do is we'll just apply this and then close it. And then we're going to go to the plastic. So let's go to Configuration Manager. We'll double click on the plastic configuration. Then we're going to go back to the feature tree or the feature manager, right click on material, edit materials, and then we're going to go down here to, we're going to collapse steel, go to plastics, and then we're just going to find a acrylic high medium impact. And then we're going to change this to megapascals. And again, no surprise here, but we're going to look at the yield strength from 275, which is a forged aluminum, to the yield strength of a plastic material, which is going to be 45. So that is quite a difference. And we're going to see that that material is going to break quite easily. So we're going to go ahead and apply that. And then we'll hit the X key, and we'll see that the color has changed. And then the last thing that we have to do is go ahead and activate the machine configuration. And inside this machine configuration, we really don't have to specify a material type. If we wanted to, we could go ahead and make it 6061 if we wanted to. But what I'm more concerned about here is that we suppress the chamfers so that it's easier for us to program that in Mastercam. So for example, I can go ahead and right-click on one of these chamfers, and instead of deleting it, because that's going to delete it across all the configurations, we're going to choose to suppress it. So when we right-click it, it's going to be the second option in the top row. And that's actually just going to turn off that geometry without getting rid of the feature. You see how the feature just turned into a grayed out feature from a colored feature. And we'll do the same thing to the chamfer number 2. And we're just going to suppress that. So now both of those chamfers are deactivated on that configuration alone. So if I go back into the configuration manager and I start toggling through all these different configurations, you'll see that the chamfers are active inside of the material configurations, which is what we want because we're testing against that geometry, versus the machine, which is strictly for programming. and we're going to import that and that alone into Mastercam. And I'm going to end this lesson here, and we're going to go into finite element analyses or SolidWorks simulations in the next video.